Hello. Good. Hello, sir. This is N. Kumar from ITB section, and my roll number is 2295181286. And today my Tech Talk AAT subject is compiler design. The compiler design, and the topic of the AAT is learning executable semantic parsers for natural language understanding. Introduction to executable semantic parsers. Executable semantic parsers translate language into executable code or structured representation. They are essential for tasks requiring precise interpretation of user intent, such as dialogue, system, and task oriented applications. The focus is on creating models that can understand and execute commands in a programming language or logical form. Learning semantic parsers. Manually programming robust semantic parsers is difficult due to complexity of the task. Semantic parsers can be learned automatically from the sentences paired with the logical form. Here is a diagram that shows the relationship between semantic parser and semantic parser learning. There is a natural language and MR training exercise. Using natural training, we are train the MR, which takes input to takes as the input to semantic parser learner, and using natural language processor, the semantic parsers will generate meaningful rep means representation. Natural importance of natural language understanding. Natural language understanding NLU is critical for bridging the gap between human language and machine comprehension. Effective NLU enables applications to interact seamlessly with users, making technology more accessible. It enhances user experience by allowing for more intuitive, intuition interactions with software systems. NLU, natural language understanding, is a one part of natural language processor. Here are some of the examples are given that are related to NLP and NLU, like named entity recognition, NER, parts of speech, tagging position, text categorization, syntax parsing, conference resolution, semantic question answering. Overview of semantic parsing. Semantic parsing involves mapping natural language sentences to formal representation of their meanings. It encompasses technique that ensures accuracy in interpreting complex queries and commands. The goal is to generate outputs that can be executed directly, such as database queries or API calls. Semantic parsing, dependency parsing, and semantic role labeling and fragmentation. Types of semantic parsers. There are various types of semantic parsers, including rule-based, statistical, and neural network models. Each type has its strengths and weaknesses, which affect performance and applicability in different contexts. Neural semantic papers in particular have gained traction due to their ability to learn from large data sets. Parser, top down parser, bottom up parser, recursively descent parser, LL1, LR parser, operator precedence parser, and LR parsers are LR1, SLR, LALR, CLR, LR, simple LR, LALR, and CLR. Challenges is challenges in executing challenges in learning executable semantic parsers. One of the primary challenges in the is the ambiguity present in natural language, which can lead to misinterpretation. Another challenge is the need for extensive unwanted data for training, which can be difficult and costly to obtain. Additionally, ensuring that the generated code is both correct and executable adds complexity to the learning process. Learning executable semantic parsers for natural language understanding is a paper which has abstract introduction about the learning executable semantic parsers for natural language understanding. Data collection and annotation. High quality data sets are crucial for training effective semantic parsers. Data collection may involve crowdsourcing or automated methods but requires careful curation to ensure accuracy. Annotation processes often need more domain enterprise to create meaningful training examples that reflect real world usage. Data collection, forms and questionnaires, interview, observation, documents and records, focus groups, oral histories, combination research, online tracking, online marketing analytics, social media monitoring. Training techniques for semantic parsers. Semantic parsers can be trained using supervised, unsupervised, or semi supervised learning techniques. Transfer learning has emerged as a valuable approach, allowing models to leverage knowledge from related tasks. Reinforcement learning can also enhance parsers' performance by optimizing for accuracy in executing commands. Learning semantic pa- Learning semantic parsers. Manually programming robust semantic parsers is difficult due to the complexity of tasks. Semantic parsers can be learned automatically from the sentences paired with their logical form. Evaluation metrics for performance. Evaluating the performance of semantic parsers involves various metrics including accuracy, precision, and recall. Execution accuracy is particularly important as it measures the ability of the parser to produce correct executable outputs. User studies can provide insights into real world usability and effectiveness of parsers in application. Four types of performance metrics: business performance metrics, project management metrics, employee performance metrics, sales performance metrics. Applications of executable semantic parsers. Executable semantic parsers find applications in voice activated assistants helping users performance tasks through natural language. They are also used in data querying systems where users can formulate questions in natural language. Other applications include programming aids and automated customer support systems that understand user queries. Semantic parsing. Learning executable semantic parsers for natural language understanding. Farshad Norvesh. Fut- Future directions in semantic parsing. Ongoing research is focused on improving the robustness and generalization of semantic parsers across domains. There is an increasing interest in incorporating contextual information to enhance understanding the execution accuracy. The future of semantic parsing may involve more interactive learning approaches, allowing systems to adapt to the user feedback. Thank you. And once of all, we recall what are the main subheadings we are discussed. Firstly, the topic name is learning executable statement semantic parsers for natural language understanding. And the firstly we had seen that introduction to executable semantic parser. Later what is the importance of natural language understanding in semantic parsers, what is their role, that like we are studied about that. It's an overview of semantic parsers and types of semantic parsers, or there are two types, mainly two types of parsers, and later they are classified into different types. And we have also seen the challenges in learning executable semantic parsers, and data collection and annotation, how the data is collected, and how we can annotate the data, and the training techniques for semantic, how can we train the our parser to uh, execute properly, and to maintain the compile what the code, what the, and to maintain a great accuracy, and evaluation metrics for performance like accuracy, precision, and recall. Applications also we have seen, and what are the future directions in semantic parsers. These are the things we are learned till now, and thank you for this opportunity.